This is Pre-Calc section 5.5 part 2. In part 1 we solved exponential equations by taking the log or the natural log of both sides. This video will cover starting with natural log equations or log equations and working our way backwards to solve, and the way we will solve is to convert to exponential. There are several different types of log equations, and one log equation is if you have the word log or natural log written on one side. And if that's all you have, then it's very easy to convert back to exponential form. And I'm going to do this one first. So exponential form would be 3 to the third equals this argument, which is x cubed minus 37. So in one move, we have gotten rid of the word log, and this is just a plain old equation we can solve. 3 cubed is 27. This is x cubed minus 37. We want to get the x alone. Add 37 to both sides gives me 64. This is x cubed equals 64. To undo cube root, to undo cubed, we need to do the cube root of both sides, which gives me x equals 4. And remember, with log equations, you need to check. And if you don't want to do the whole full check, at the very least, you need to plug 4 back in here and be sure that you are not taking the logarithm of 0 or the log of a negative number. 4 cubed is 64. 64 minus 37 is 27, which is fine. We are not taking the log of a negative number or of 0. This one with the natural log, the easiest way to go is to put a little e to the. So I'm making the ln of 2x the exponent that goes on e, and I'm making 4.6 the exponent that goes on e. And the reason I want to do that is that e and natural log are opposites. So all I get over here is 2x, and this is e to the 4.6. Now MathLab is going to ask you for an exact answer, and then it will ask for a decimal approximation. So don't use your calculator yet. To get x alone, divide both sides by 2, and my exact answer is e to the 4.6 over 2. Then you can use your calculator and get the decimal approximation if they ask you for it. Sometimes they do, sometimes they don't. And this would be negative 5.885. In this case, they asked to go to the thousandths. A little different than the last one. The last one I said it was very easy to do if we only had the log word written one time. Well, we've got the log word written twice. This tells me to go back to these properties right here. You should remember these properties from college algebra and from a couple sections ago, and that is the log of a product becomes the sum of two logs. The log of a product becomes the sum of two logs. Well, what I have is the sum of two logs. So I'm going to go back to the log of a product. So this becomes log base 6 of the product, x times x minus 5. Still equals 2. Now I have the word log written one time, and I can now convert to exponential form. 6 to the second equals x times x minus 5. I could have already distributed, but I'll do that on this step. 6 squared is 36. Distribute x through there is x squared minus 5x. This is a quadratic equation. You need to get your 36 over to the other side because our strategy will be to factor and solve. And if you're going to factor, everything has to be on one side equal to 0. So bring the 36 over, and we have x squared minus 5x minus 36 equals 0. It does factor, but if you choose not to factor, you could use the quadratic formula. That takes a little more work. So it factors as x minus 9, x plus 4. So solving each of those equal to 0, I get x equals 9 or negative 4. Be sure you check. If you put 9 right here and 9 right here, you are taking the log of a positive number, and that's perfectly acceptable. But look at the negative 4. If you put negative 4 in here or in here, you're taking the log of a negative, which we can't have. And that's why negative 4 gets thrown out. Our only solution is x equals 9. Same kind of problem where we have to use a property. This one happens to be natural log. Now, notice natural log is written on both sides, so this becomes like a third type problem. Go back a second and look at the property. The log of the quotient becomes the difference of the logs. The log of the quotient becomes the difference of the logs. So what I have right here is the difference of the logs, which means this needs to go back to the natural log of the quotient. What I always think about is when I see a minus, I'm thinking about that being a big, long fraction line equals natural log of 9. Now this is nice because if you have natural log written one time on each side, we've done our condensing, we can drop the natural log and we have a plain old equation. X plus 3, 8x plus 3 over x equals 9. I'm going to write it as 9 over 1 because I like to cross multiply. Cross multiply there gives me 9x. Cross multiply there gives me 8x plus 3. And subtract 8x from both sides and we get a solution of x equals 3. Plug that back in right here. That's okay. We would be taking the log of 27, or natural log of 27. Put a 3 in here. We'd be taking the natural log of 3, and that's okay. All of those were problems that we did in college algebra for solving log equations, so that should have been review. This one is a little different. This is an exponential equation, so we're back to exponential equation, but it's an exponential equation that is in quadratic form. Quadratic form is when your first power is exactly twice your middle power. If that's the case, we can think of it as if it were a quadratic equation and factor it as such. What needs to go in the front here is e to the x. Remember, there's an easy way to decide what goes in the front, and that is whatever the power is in the middle goes to the front. Now that's only after you have verified that this is in quadratic form. 2x is twice x. Then my signs are both minus, and I'm saying what multiplies to give me 11, that adds to give me 12 would be 11 and 1. Set each of those equal to 0. And normally I don't write out this step, but I do need to write it out with this. So I have e to the x minus 11 equals 0. E to the x minus 1 equals 0. Solve each of those, add 11 to both sides, and I have e to the x equals 11. And the only way I can solve this is to take the natural log of both sides, because natural log e goes away, and I have x equals natural log of 11. And they don't want you to use your calculator. That's what they want you to enter, natural log of 11. This one, add 1 to both sides, we have e to the x equals 1. And you should know that x equals 0. The only power you can put on e to create 1 is 0. So there's our two solutions.